Hello, good morning to all. Now let's see non-existence of simultaneous limit. Okay. First of all, we have to take paths along x-axis, that is keeping y is 0, and obtain limit, and try for this path, that is path along y-axis, and we have to keep x is equal to 0. If limits along both paths is equal, then don't conclude that simultaneous limit exists. But if limit along both paths is different, then you can directly conclude that simultaneous limit does not exist. Again here, for this paths here. Again here, for this paths limit is set. Again for this path, limit is equal to limit along this path. Then again don't conclude that limit exists. Okay, that means limit along limit along these two paths as well as limit along this path is set, then don't conclude that simultaneous limit exists. But if limit along these two paths is set and limit along this path is different from these two, okay, different from limit along these two paths, then you can directly conclude that limit does not exist. Similarly, as well as limits are set, don't conclude that simultaneous limit exists. But somewhere, if we get different limit, then you can directly conclude that simultaneous limit does not exist. Therefore, here we consider some examples. Here we consider some examples. For that purpose, that is simplest one example. Example 1. That is, consider the function. Consider the function f of xy is equal to x minus y upon x plus y, provided both xy not equal to 0, 0 and is equal to 0 otherwise. Now we'll see here for the solution. Okay. For the solution, consider a path. Consider a path along x-axis. X-axis. That means we have to put y is equal to 0. That is, we have to put y is 0. Y is 0. Okay. For that purpose, here, okay, consider path. So your first path, can take this first path. Now, here, f of, we have to keep y equal to 0, therefore function is x0, therefore it will be x minus 0 upon x plus 0. This will be x upon x, that is 1. And for that purpose, we have to obtain limit. Okay, limit okay. For that purpose, limit xy tends to 0 0 of f of xy, it is same thing as to write limit x tends to 0 of f of x0, and that is limit x tends to 0 of 1 is 1, and and limit xy, okay, this will be limit along x axis. Now consider a path along y-axis. Y-axis. That means we have to put x is 0. Okay. Now therefore we are having 0 y. Therefore it will be 0 minus y upon 0 plus y. Therefore this value is minus y upon y. That is minus 1, and therefore limit xy tends to 0 0 of this f of xy is nothing but limit, it is y tends to 0 of f of 0y, and that is nothing but limit y tends to 0 of minus 1. Therefore this value is minus 1. Now here path limit along these two paths is different. Here is 1, here is minus 1. Therefore here limit along, here limit along different paths, different paths is different. Different. Simultaneous limit does not exist. Hence, simultaneous limit does not exist. Does not exist. Similarly, we will take another example of this one. Consider a function. Consider a function f of xy is equal to x square minus y square upon x square plus y square, provided xy not equals to 0 0 is equal to 0 otherwise. Okay. Now okay, therefore for solution a path along x-axis, that means we have to put y is 0. Therefore f of y is 0. Therefore this function is nothing but x square minus 0 square upon x square plus 0 square, that means x square upon x square, that is 1. Okay. Then second one, that is path along y-axis. Let to put x is 0. Therefore f of okay. Don't write here. Okay. Limit x of xy is same thing as to write limit x tends to 0 of f of x0, and therefore limit x tends to 0 of 1 is 1. And okay, for this one, path along path along y-axis. They have to put x is 0. Therefore, here f of 0 y, this will be 0 square minus y square upon 0 square plus y square. It will be minus y square upon y square, that is minus 1. Therefore, here limit xy tends to 0 0 of f of xy is nothing but equals to limit y tends to 0 of f of 0 y, and therefore limit y tends to 0 of 0 y, that is minus 1, therefore limit is minus 1. In this case, here limit along different paths, different paths along different paths is different. Okay, hence simultaneous limit does not exist. Does not exist. Similarly, we'll take an example number 3. Consider a function here. The function will be a xy upon x square plus y square. Then in this case, what will function here? Limit path along x axis. That is, you have to keep 0. That means x into 0 upon x square plus 0 square. Therefore, it will be 0. And therefore, this function we are having this value of 0 is 0. Along y-axis, we have to keep 0. Therefore, here the function is nothing but 0 into y upon 0 square plus y square. Therefore, it is a 0. Therefore, this limit is 0 here. Now, in this case, for these two paths, limit is 0. Therefore, we can't conclude that simultaneously does not exist and it is 0. We have to test for another path. Okay, that is the C path. Path along straight line y equal to mx. Y equal to mx. Therefore, f of xy is nothing but f of x mx, and therefore this is nothing but x y equals by mx, then x square plus mx square simplifies to here mx square upon x square m square x square, and if we keep mx square upon x square into 1 plus m square. Okay, in this case, cancelling x square, we are having 1 plus m square. Okay, therefore, limit xy tends to 0 0 of this function f of xy is equal to limit xy tends to 0 0 of fx mx, and it will be limit xy tends to 0 0 of 1 upon 1 plus m square. Okay, you can directly take x mx. Okay, here we are having mx tends to 0, it is equal to write only x tends to 0 of this quantity, and this one is nothing but 1 m square. Here limit depends upon depends upon m, depends upon m, hence limit hence limit along different paths is different, along different paths is different. Okay, along different paths is different. Therefore, we can conclude that is simultaneous limit does not exist. Simultaneous limit does not exist. Okay. Now, again, one thing is common here. We take this as a note. Note that for path x is equal to my. What will happen? Therefore, note that for path we have f of xy is nothing but f of my, therefore it will be nothing but my into y upon my square plus y square. In this case, my square upon m square y square plus y square, that is my square. Then you can y square common, therefore it will be m square plus 1, m square plus 1. And cancelling this factor, we will have my square. Okay, I think this is somewhat changed here. Here should be m upon this one. Okay, here it will be m square plus 1. Okay, no problem. And therefore, limit xy tends to 0 of f of xy is equal to limit y tends to 0 of f y, and this will be equals to limit y tends to 0 of function, this one is m upon m square plus 1 is nothing but m upon m square plus 1. Again here limit depends upon m, hence limit along different paths is different. Therefore simultaneous limit does not exist. Simultaneous limit does not exist. Okay. See here we can directly conclude that simultaneous limit does not exist for this path. But again, for this path, we are getting different limit, and in this case, simultaneous limit does not exist. That means, in some cases, you may get so many paths where with these parts, we can conclude that simultaneous limit does not exist. Okay. Therefore, for the proof, that is very important remark. That means, in some cases, we may get more than one path, more than two paths, where a limit is different, where limit is different for different from other paths. Okay, that is very important remark. In some cases, we may get one or more paths where we are getting different limits as compared to previous paths. Okay. Now, this will be example number 3. Now, come to example number 4. Okay, here, consider the function. Consider the function f of xy is equal to xy square upon x square y raised to 4th. Okay, I think it is getting some problem. Okay, provided this xy is not equals to 0, 0 is equal to 0, otherwise. Okay. We put in y square, y raised to 4th, y raised to 4th. Okay, no problem. Okay, no problem. Okay. Now, path along x-axis. That means you have to put y0. Therefore, f of x0, this function given x0, that means 0 into x into 0 square upon x square plus 0 raised to 4, in this case is 0. And therefore, limit xy tends to 0, 0 of f of xy is nothing but limit x tends to 0 of f of x0, and in this case, limit x tends to 0 of 0 is 0. Then similarly here, path along y-axis. Again, in this case, you have to put x is 0, and therefore f of 0y is nothing but 0 into y square upon 0 square plus y raised to 4, and in this case, limit is here. That will be 0. Okay, and therefore we can consider here therefore Okay, here limit xy tends to 0 of f of xy is nothing but limit y tends to 0, y tends to 0 of 0 y. Therefore, limit y tends to 0 of 0 is 0. Here, along this path, we'll have these two limits set. Now, if we consider the path y equal to mx, what will happen? For path y equal to mx, what will happen? Y equal to mx. What will happen for this one? If we keep here quantities, that will be x mx square. Okay, for this one, and x square, then mx raised to fourth. What will happen? Simplify here. That will be mx cube upon x square plus m raised to 4 x raised to 4. In this case, we can take x square common. Then what will happen? Then in this case, if we take x square common, therefore it will be okay mx cube upon x square into 1 plus m raised to 4 x square. X square cancelling, it will have mx and 1 plus m raised to 4 x square. Then in this case, what will happen? If you take x, limit x tends to 0, this limit is again 0. Therefore, similar things happens for paths y equal to mx square, y equal to mx cube, y equal to mx fourth, and in this way. Similarly, for paths, if we take this path, x is equal to my. Again, in this case, we are having in this case, limit is set. Then x is equal to my square, again limit is set. X equal to my cube, it is limit set. In this way, for all paths also limit is set. But we have to think out of box, that is whether we are able to take a path such that degrees of numerator and denominator are same. Therefore, here we have to consider a path here for paths then y equal to mx, y equal to mx square, and so on, y equal to mx cube, and so on, as well as x is equal to my, x is equal to my square, x is equal to my cube, and so on. Limit is 0. Now consider a path such that degrees of numerator and denominator becomes set. For that purpose, you have to consider limit y is equal to, noting this is x is equal to y square. Therefore, what will happen? Limit, okay, function f of xy is equal to limit y square y, and therefore it will be x, that is y square into y square upon y square square plus y raised to 4. Simplify here, y raised to 4 upon y raised to 4 plus y raised to 4. Therefore, y raised to 4 upon twice y raised to 4. Therefore, it y square plus cancel, that is only we are getting half. In this case, xy tends to 0 of f of xy is same thing as to write. Here only y is appearing, therefore limit y tends to 0 of f of y square y, and therefore limit y tends to 0. This value is half, and therefore there is no variable y appearing in this case. Therefore limit is half. Now here in this case you see here that limit for this path is half and other path it is 0. Therefore here we got limit half different from paths having limit 0. Therefore, we can say limit along different paths is different. Limit along different paths is different. Different paths is different. And therefore, we can say that is simultaneous limit does not exist. Simultaneous limit does not exist. Does not exist. See here, for this function. Also, we will take here note regarding another functions. Okay, that is for function, for the function f of xy is equal to xy cube upon x square plus y raised to 6, provided xy not equals to 0 0 0 0 and is equal to 0, otherwise we are mentioning only path along which we are getting different path limit, that is nothing but your path is nothing but x is equal to y cube. This will be the path for which we are getting different limit. See here, why we have chosen this path? Because if we keep x to y cube, then it will be y cube, the degree will be 3 plus 3, that is 6. Here, if we keep x to y cube, that means x y cube square. That means y is to 6 plus y is to 6, that means twice y is to 6. And therefore, in this case, degree of numerator as well as denominator is 6. Therefore, always concentrate on the step that make try to equalize degrees of numerator and denominator equal. How to take this one equal? Choose this part. The degrees of numerator and denominator should be equal. Then there is no problem at all in such cases. Okay. Again, we'll take another function here. Okay, if time permits. Okay. For functions, for the function f of xy is equal to, that will be x cubed plus x minus y square, provided that both x square upon this one or x cube here, no problem at all. X cube is equal to x cube this one, provided the x y not equals to 0 0 is equal to 0 otherwise. Now, for such functions, try to make degrees of numerator and denominator same, so that here degrees of numerator and denominator will be same, provided this term will vanish. If this term will vanish, then degrees of numerator and denominator will be same.